let's jump right into this explainer. Today, we're unpacking how a massive, overwhelming geopolitical and environmental macro crisis is actually being solved on the ground by a micro-technological solution. We're looking at a completely fascinating case study that bridges the gap between giant global supply chain headaches and hyper-local innovation. It's called 905 Wood's Digital Refinery.
Now, I know it seems almost impossible to connect a standard consumer gadget, the kind of smartphone you probably have in your pocket right now, with the multi-million-ton international waste trade. I mean, it kind of sounds like science fiction, right? But it's happening, literally right now, in the logistics sector. To really get how this works, though, we first need to understand the sheer scale of the problem we're up against.
Take the year 2034, for example. That single number represents the absolute terminal year for Ontario's regional landfill capacity. That's exhaustion. Done. If we don't drastically change course, by 2034, there will literally be nowhere left to put our waste. Period. It plunges us straight into the incredibly high-stakes reality we're facing today. We're on a ticking clock, and the pressure? Well, it's mounting from every possible side.
Which brings us to Section 1, the capacity cliff crisis.
So let's break down this capacity cliff. And, this isn't just some industry buzzword. We're talking about an existential waste infrastructure crisis, driven by compounding regulatory and physical deadlines that are just pushing us right to the brink. First up, 2026. This brings the implementation of the Circle Layer Levy. That's going to slap a $5 to $60 per ton tax on industrial waste. Ouch. Then, fast forward a bit to 2029. We get a phase-in ban on clean wood in landfills. Actually, scratch that. What that really means is burying it straight up becomes illegal. And finally, you have that terminal 2034 date for total capacity exhaustion. It becomes pretty obvious, right? The old legacy system of just hauling and burying mixed waste is, well, mathematically and legally doomed.
Moving on to Section 2, the USMCA Trade Shield.
Because, of course, as if the domestic capacity cliff wasn't enough of a headache, we also have to look beyond our borders. Every single year, we export about 3.46 million tons of waste to Michigan, and that flow, it is incredibly vulnerable to geopolitical shifts. You've got temporary tariffs in play right now, like Section 122, but those are child's play compared to the terrifying, indefinite trade barriers looming over us, like the pending Section 301 tariffs or the massive USMCA Chapter 4 transshipment penalty. That transshipment rule alone could slap a 40% penalty on mixed loads just to block non-market goods from entering the U.S. Honestly, these penalties could permanently choke the border. So you have to ask yourself, how on earth does a local logistics company even survive this?
That's where we hit Section 3, the Digital Refinery Architecture.
To survive this intense border friction and skyrocketing local taxation, 905 Wood essentially built a force field. They developed a 6-layer architecture that completely drives their 8-step operational life cycle. The absolutely crucial starting point here is what they call the sentient bridge. Think of it as a way to connect the physical, muddy chaos of a construction site directly into perfect, pristine digital order. So how's it work? First, it does a visual scan of the wood pile in under 2 seconds. Second, you get sensor fusion using Gemma Nano on-device AI, which is actually paired directly with the driver's audio notes. Third, cloud processing kicks in to handle the massive, complex regulations that, let's be real, no single human could ever memorize. And fourth, it automatically generates fax-ready, final compliance documents for the border. It literally takes all the guesswork out of the driver's hands.
Let's look closer at the tech in Section 4, Edge AI on the job. Okay, we really need to talk about the hardware running this system, because this is where the sheer genius of it lies. It isn't some massive, ridiculously expensive industrial server bolted into the back of a truck. No way. They are literally just dropping an off-the-shelf Google Pixel 10 Pro into the non-air-conditioned cab of a truck. And no, they aren't using it to scroll social media. They're leveraging its dedicated AI processor to run incredibly complex compliance models right there at the muddy edge. It basically acts as a distributed inference server, powered by that Tensor G5 chip. Because it has a dedicated neural processing unit, it can maintain 8 hours of continuous thermal stability without throttling, even in the heat. Combine that with a Titan M2 hardware root of trust and a super robust offline mode for those annoying network dead zones, and you essentially have a rugged, industrial supercomputer just sitting right there on the dashboard.
I absolutely love their design philosophy for this. Your camera sees color, not chemistry. That hits the nail on the head. It perfectly highlights why the system operates strictly on the precautionary principle. Basically, the system automatically assumes all wood is chemically treated and highly toxic until the sensor fusion and AI can definitively prove its purity. It inherently distrusts the basic camera lens. It forces a much deeper, multi-layered level of verification before any load is ever approved.
Section 5, Hub and Spoke Mothership Logistics.
All right, so now that the data is totally secured at the edge by the Pixel phone, the actual physical logistics of moving massive amounts of biomass completely transform. I mean, the old model was literally just haul and bury. That meant dragging around air-filled mixed bins directly to landfills and just eating those escalating $60 per ton circular levies. It's a massive financial drain. But the new model? That's wood-only diversion. This decoupled billing model separates the physical logistics from the disposal side using a hub-and-spoke system. So smart contractors can just bypass those expensive government levies entirely.
And here's where scale comes in. Aggregating these processed chips into a massive 144-yard trailer is pretty much the only economically viable way to supply these distant biohubs. So you have your smaller 20 and 40-yard bins collecting waste out at the distributed spokes. Then, everything comes into the Hamilton hub. There, the wood is sorted, chipped down to a very precise 2 to 4 millimeters, and dried to under 10% moisture. Finally, the whole shebang gets loaded into these massive 144-yard walking floor trailers, which the team affectionately calls the mothership. This allows them to bypass traditional transfer stations entirely, delivering perfectly clean, verified feedstock straight to bioeconomy partners like Char Technologies.
Which brings us to the financial payoff in Section 6, Carbon Dividend Economics. Because at the end of the day, all of this high-tech digital tracking and massive physical logistics coordination boils down to one absolutely crucial thing: a complete economic transformation for the waste industry. I mean, just listen to this number, $5,027. This represents the incredible mothership dividend. We are talking about the sheer financial value generated from a single 19.15-ton trailer load, and it is all made possible, literally every cent of it, purely because the provenance and purity of that wood was perfectly tracked and verified by the system.
Let's quickly break down the cork math here. By using digital product passports to prove the wood was diverted, what they call saw blade to soil, and turned into biocarbon, the system actually mints tradable certificates. And hey, this isn't just some theoretical whiteboard exercise. This carbon math has undergone rigorous peer-reviewed validation by RPRA Scientific. Basically, 1 ton of dry wood yields about 0.75 tons of CO2 equivalent removed. So with carbon dioxide removal certificates, or CORCs, trading at roughly $350 per ton on the open market right now, this system effectively flips wood from a $60 per ton landfill liability into a massive carbon revenue stream. And honestly, the best part? It shares that carbon revenue right back with the waste generator. It's a total game changer.
So what does this all mean? Ultimately, this explainer highlights exactly how the Digital Refinery successfully bridges the massive gap between the chaotic, regulation-heavy world of local waste and the ultra-precise, specification-heavy world of the emerging bioeconomy. Think about it. It takes the Hamilton grit of muddy 2x4s and somehow turns it into pristine Silicon Valley data streams. It really is a masterclass in shifting standard old-school trucking logistics into a highly profitable, deeply integrated waste-as-a-service model.
I want to leave you with this provocative thought today. If an off-the-shelf consumer smartphone can literally flip an international waste crisis into a carbon-negative revenue stream, well, what other massive global supply chains are hiding billion-dollar solutions in plain sight? Seriously, think about what other huge, failing legacy systems could be completely transformed just by pushing the right microtechnology directly out to the edge. Thanks for diving into this explainer with me today. I really hope it completely changes the way you look at the hidden systems operating all around us.